So my name is Rich Pareko. I pronounce it Pareko, like the wind. My mom calls me Richard. Most of my friends call me Richie. However, I've been known to be called Dick more than a few times. I'm the business development manager for FenCan's commercial chapter. I live outside Vancouver in Coquitlam, and I wear a lot of different hats with a few different companies. I work with a lot of teams all over the US and Canada. However, my background is specifically in marketing and commercial glazing. In addition to working in business development for FenCan, for the last 16 years, I've operated a marketing agency almost exclusively for the commercial glass industry. So some of you may know me from writing for Glass Canada magazine. I was the interim executive director for the Canadian Glass Association, and I've worked a fair amount with the National Glass Association. I'm super active on LinkedIn, and if you're on LinkedIn, it would be great if we connected. FenCan's commercial chapter launched earlier this year, and we're already achieving great things. Some of the topics we're tackling include bird-friendly glass, a roadmap on pending energy legislations, best practices on contracts related to commercial glazing, education seminars, and grant resources. So the list of priorities is long and my time is short, so I'd like to take a minute to introduce the commercial chapter's technical advisor, Jeffrey Makamoto. And I'd like to introduce the FenCan commercial chapter chair, Brent Friesen, owner of Bay West Glazing Systems. So with that, let's move on to our panel session, part 3, pitfalls. I'd like to welcome for this session Jonathan Adams, Chief Operating Officer and partner of Layton Consulting. In addition to working as COO, Jonathan oversees projects that present unique technical challenges. Jonathan has worked for Layton Consulting for over 7 years. He has a unique set of skills and technical knowledge gained through his diverse background in mechanical engineering and product development. His engineering experience before becoming a glazing engineer expert includes design optimization and advanced FEA modeling techniques, leading technical research and development projects, and systems engineering of products from concept to construction. Jonathan will share important information that is critical to know for any building project where glazing is present. Gaining a better understanding of glass, the role of the glazing engineer, and the regulatory requirements involved with having glass on a building project is important for any architect or contractor to understand. Improved knowledge of commonly misunderstood aspects of glazing design, from engineering requirements to changing limitations by code, will add to the success of your projects. Part 3, pitfalls. Welcome, Jonathan and panel.
Thank you so much, Rich, for that introduction. It is a privilege to be here, really grateful to be here. I know we're getting on in the day, and so thank you so much for sticking around for this presentation. I want to give a big thank you as well to all those who have presented already, and for FenCanada for hosting this, and for all the sponsors for making this possible. So thank you so much to everybody. I really hope today to not just tell you about some of the things that we come across, but also truly try to add to your understanding, add some value to what you do in this industry. As was stated, I work at Layton Consulting, so we do specialty structural engineering for glazing systems. We're also a certified simulation lab, so we do a lot of NFRC-based thermal simulations as well. And we've today heard a lot about thermal simulations. We've heard a lot about the thermal side of glass, of windows, and the thermal aspects, which is an incredibly predominant part of glazing systems in general. So we're going to change gears a little bit here. We're going to talk a little bit more about the structural side of things, and really what I'd like to focus on is trying to dispel some of the myths and misunderstandings with regards to structural integrity, the structural side of glazing systems. So really, I'd like to just focus on 3 things, and if we can really just if we can, there's a few questions that I'd like to specifically answer, and those questions, which I'll show you in a second here, will focus on the codes and standards with regards to glazing, glass concepts, some basic misconceptions, and the RPR-SRP relationship. Now, I'll tell you more about what those acronyms mean and a little bit more about that as we go along. But if we can just cover some basic understanding from those three things and add to your understanding today, then I think we'll have succeeded in what we're trying to cover. So I'd like to start with glass standards. Now, I'm not going to cover all the standards that relate to the structural side of glazing systems. There are many different standards that could potentially apply to glazing systems. So I'm really going to just try to focus on a handful that matter most, we'll say, from a structural perspective. We've got CAN CGSB 12.1. That's commonly known as the safety glazing standard. CAN CGSB 12.20 M89. I'm going to refer to that as just M89, just for short. That's kind of what we colloquially call it at work. So we'll just call it M89 just for the sake of simplicity. ASTM E1300 and CSA A500. And you may ask yourselves, well, why do we focus so much on standards? I think there's some obviousness to it, but we all interact with glass. And in some ways that glass was not meant to be interacted with. So obviously the scope of these standards is somewhat limited. As I was preparing for this presentation, I came across this image and I learned a new word. Does anybody know what the definition, and I'll repeat the answer for the sake of those who might be online. By the way, welcome to anyone who is online. Does anybody know the definition of the word defenestration? Throw somebody or something out the window. That's right. So with all the codes, with everything that we've talked about today, I understand it gets frustrating sometimes, and we would like to be fenestration specialists, but some days we would like to be defenestration specialists. But that's part of what hopefully the standards will help us rein things in with. Okay, so we're going to start with this safety glazing standard. CAN CGSB 12.1, so safety glass. Now, what makes glass safe? There's all sorts of ways that glass could potentially be safe, right? There's all sorts of ways that you could potentially try to make a building or a project more safe. So what exactly are we talking about when it comes to safety in glass? So this is one of the questions I'd like to answer today. Another question is, what are tempering and lamination? And I should say, I understand that there's probably a wide range of understanding with everybody here. Some may be completely new to this industry and not really know much about what is what, and that's totally okay. For those who find themselves in that situation, welcome, and hopefully we can bring you up to speed. But I also want to present some information that hopefully will also cater to those who've perhaps been in the industry for a long time and add to your knowledge. So we'll try and answer that question as best as we can for everybody. And how do I know if glass meets the standard? So the basic answer to the question, what makes glass safe, is tempering and or lamination. So the safety glazing standard is focused on one key part of safety and one part only, and that is reducing the likelihood of injury to a person when they're interacting with glass. In the event when glass breaks, and hopefully it doesn't, but when it does, we want to minimize the amount of injury that happens. That's really it. You know, if you have a project where, let's say you are tasked with designing or providing a blast-resistant door of some kind, you might need a different level of safety than what this particular code is going to be offering you. So it is limited in what it does cover. And the building code is pretty explicit. Now by building code, I'm referring to the National Building Code and of course our provincial building codes. We'll be pretty specific about which situations require safety glazing. I'm not going to go over all of those references, but in general, this is one of the points I'd like to hit home. It's really just limited to reducing injury. The standard also does not address strength or durability or fire-rated things. And the reason, it's actually an interesting thing because when we need glass that provides more strength, we look for glass that has tempering. we look for glass that meets the safety standard, but the safety standard itself does not describe how strong glass should be. It inherently, the way that this particular code describes how the glass is to react under breakage when it is tempered, also implies that the glass has reached a certain amount of tempering that would provide the strength that we commonly refer to. You may have heard that tempered glass is approximately 4 times stronger than annealed glass, right? So that exact strength value is implicit in the fact that this glass has been tempered to this standard. So that's important to realize. And I should mention as well, if there are any questions as we go here, we'll just save the questions until the end for our panel, since we've got such a great panel here. I don't want to shortchange them. So what are tempering and lamination? So a quick breakdown of those things. Tempering, when you break the glass, now this is, again, talking about it from a safety perspective, so many of you may know, when you break tempered glass, it breaks into many, many small pieces. And the idea is when those small pieces are falling on someone, they'll have much less inertia and much less probability of hurting somebody. And as I mentioned, tempered glass is approximately 4 times stronger than annealed glass. And to break tempered glass, it's quite easy. You just need to take a hammer and just knock the edge just a little bit, just chip that edge just a little bit, and the whole glass goes. So it has some fairly easy ways to break it, which, for example, in guardrail applications and so on, you want to make sure that you're protecting those edges in situations where it's applicable. Tempering does not make the glass more stiff. So you can make the glass stronger by tempering it, but it's not going to make it more rigid. That's a common misconception we come across quite a bit. Then lamination. Lamination is essentially taking 2 pieces of glass, 2 thinner pieces of glass, and sort of gluing them together with a polymer interlayer. And there's some common interlayers that are used, but the point of lamination in the sense of safety glass is to help the glass stay in its opening after it's broken. That's provided that you have good edge support to keep the edges in, otherwise the glass just falls out as one sort of, we commonly call it a wet blanket, which could be even more dangerous than if it was not laminated in the first place. So lamination has its place, but it's not safe in all applications. Lamination does not make glass stronger, unless, I mean, if you were using tempered panes of glass and laminating those tempered panes together, which in and of themselves are more strong, then yes, you would have strong glass. But lamination itself, adding a squishy center to the core of your glazing, to the center of your glass, is not going to make the glass more strong. It's going to make it more weak or less rigid in general. So with lamination, you typically get more deflection when glass is in a bending scenario. Now, I just want to talk a little bit more about tempering. Tempering is a black box for some people. It was for me early on, just trying to understand what tempering was actually doing. So I just want to quickly describe that. To temper glass, you heat glass between 600 and 700 degrees, and then you quickly cool the surfaces. Really, really quickly. You blow cold air at those surfaces for a brief moment, and that cools those surfaces and forces the surfaces of the glass to be in a residual or permanent compressive state. Glass characteristically will break when under tension. So we're trying to prevent it from having too much tension on the surfaces that are going to be experiencing the most stress. So by tempering it, we force it into compression, which is the opposite of tension, making it so that we would have to first overcome that compression to then start to get into a tensile state or tensile stress state. So and I'll talk a little bit more about that in some diagrams. Just a quick few more notes on this. Here we have these 2 pieces of glass are annealed glass. Now, this would be representative of like a 2-sided support piece of glass. This is just these are just single pieces of glass supported simply on either side with a load in the middle. This one here is not loaded. This one here is loaded. And the same thing for this tempered scenario here. Now, when you bend something, you can see here by this diagram, on the top of not just glass, but any sort of beam or any sort of plate that you're bending in this way, it will have compression on the top surface because it's sort of shortening it. The length of that arc is shortening. And you'll have tension on the bottom surface. So that's a problem, because remember what we were saying is it's in that tensile stress state where glass is going to want to break. So you can see here in these small charts on the side, this is the thickness of the glass. Here's the top and here's the bottom. This is sort of a graph that describes how much compression or tension is on either of those sides, or top and bottom. So in this case, with this annealed, unloaded piece of glass, there's no stress at all, right? This line down the middle is 0. So there's no stress at all. We apply a load, and all of a sudden we have compression on the top of the glass and tension on the bottom, right? So that's the green here is representing the compression, the red representing the tension. So, again, like we were saying before, we want to force this glass to have compression to begin with. So we do that rapid cooling in the tempering process, and that cooling forces permanently the top and bottom surfaces to be in high compression. And the center just happens to be in a little bit of tension, which doesn't matter so much because in a bending scenario, that's not where your tension is happening anyway. So if there's a little bit in the center, that's okay. So then if you were to combine the amount of stress that you would get with the amount of stress that you first have in the tempered scenario, you end up with something like this, where you have even higher compression on the top surface of the glass. That's why I made this line a little bit thicker green to indicate that there's even more compression there, and potentially none, if not, at least not nearly as much tension on that bottom surface. That's why tempered glass is more strong. That's what makes it become stronger. Now, why is that important? Well, as I mentioned before, making sure that glass meets the appropriate standards indicates that that glass has gone through a tempering process that would provide the expected strength that we're looking for. And as engineers, that matters. If I see a piece of glass that has an etching logo on it that indicates that it's been tempered, but it's from Europe, although there are some similarities for sure between those two standards, Europe and here, for example, there might be some slight differences in that heat treatment process. And although it's likely going to be generally strong enough, I need to be able to rely as an engineer on pretty specific information to know how strong a piece of glass is going to be. That's why, and I'll talk about it in a little bit here as well in another slide, to make sure that that glass has that logo on it. Of this slide right here. So here's an example of that tempered logo. This one is specifically from Garibaldi, and it lists the place where it was manufactured or tempered, and the standards that it meets. In this case, it does list the CAN CGSB 12.1, and also the ANSI Z97.1, which is the US standard, which are harmonized, but our particular standard states that at least this CAN CGSB 12.1 is listed on that etching. So that's how you know if your glass has been tempered appropriately for Canadian building projects. And our building codes specifically state that any glass used in building applications that's supposed to be safety glass needs to meet this particular standard. And again, as I mentioned, although it doesn't cover strength, if we do require, if your project does require tempered glass for strength purposes, it would also need to meet that standard. What an etching does not mean, I guess I sort of explained it, but it does not mean that your glass will be resistant or strong enough. Just making glass tempered doesn't automatically mean it's going to be strong enough for all applications. It may not be thick enough still, may not be rigid enough. There's further analysis that needs to be done. A common misconception is, for example, in a guard load application, that 12 millimeter tempered glass will work for all exterior balcony guards. That's simply not true. It will work for many cases, but there are many cases in which it will not. So just having that tempered logo is not enough. Having the etching, as I mentioned, does not mean that it will meet the Canadian standard, unless it says it does, of course. So pay particular attention to glass, especially if you're sourcing stuff overseas. You want to make sure that that glass meets the Canadian standard. It also does not mean that the glass has been tested for guard applications.
I got to stop you there because what if I bring product over from Europe as a glazing contractor and I install it using European standard contemporary and there's a problem?
Mm-hmm.
Where's the liability line?
That's a very good question. Well, can we save that for the panel? Okay. It's his birthday. He can do whatever he wants. Yeah, we will answer that, Terry. I'll do my best. Okay. The next two I'll sort of combine together. They are different. So the M89, I said we would just refer to that as M89, and ASTM E1300. They are referring to determining what the load resistance is of glass or of glazing units. They both focus on that. They're different in that the old one, M89, the M89 means it came out in 1989, so keep that in mind. It's been around for a long time. It's actually been, what's the word? It's been discontinued, redacted. It's just very outdated now, and but it's still listed in our building codes as being one of these two relevant codes that we engineer to. So we'll talk more about that. But yeah, they are important to be familiar with in the sense of, like, as glazing manufacturers, you don't necessarily need to be well versed in these codes, but if you have a glazing contractor who is engineering for you, you will want to make sure that they are familiar with those codes, because although they are putting their stamp on your product or on your installation, there's still a certain amount of liability with everybody in terms of installation and so on. So it's important for you to be confident that what is being engineered meets these standards. And I say that because we do come across many instances in which it's clear that that has not been the case. Now, I know there's probably not a lot of companies here that deal directly with glass guards, but I do want to cover it a little bit because, well, because we see more and more systems where, like Juliet balconies and so on, where there is an integrated glass guardrail in some of these glazing systems on patio doors and so on. So I do want to cover this. It is relevant, and it's one of the perhaps more misunderstood topics. So this particular picture here does not meet building code. Now I want to take a quick couple comments, and I'll repeat it through the mic for those online, of what you think might be wrong with this. Why do you think this may not meet building codes? I've got a hand here and then a hand over here. No top rail, no secondary guard, that's right. M89, way back in 1989, said that you needed that. So anything you see without it, almost everything you see without it, wouldn't meet that. Al? And the same one. It's not laminated, so another standard that we'll talk about in a sec here, CSA A500, provides a path to have glass guards without a top cap, but you can kind of tell there's no interlayer there. It needs a specific kind of interlayer, which we'll talk about. But yeah, not laminated. It's got no top cap. What's this over here? This is water. This is ocean or some sort of a big lake. So guard rails need to take more than just guard load. They need to take wind load too. This is off of a lake, which means wind loads are probably going to be high. Now, if you were to put a large wind pressure on this, what do you think would happen down here? Yeah, it would probably break. Yeah, I think that's a safe assumption. You've got these little spigots down at the bottom, and you'll get some pretty intense stress concentrations right where that glass is interacting with those steel. Even if you've got a polymer in there, it's not a good idea. That's another reason why this would not meet code, in the sense that it will not, the glass simply is not resilient enough to be able to handle those sorts of stresses. Yeah, I think that pretty much covers it. I mean, we don't really know what this is mounted to. I suppose you could postulate and say that perhaps this is just mounted to the top deck board or something like that, and maybe the way that it's fastened is inadequate, but I guess it's not worth speculating. But long story short, this just doesn't meet building code. Yeah. Again, it's your birthday, so.
How come we see that all over the North Shore? I mean, you see it everywhere.
Yeah, it's because there are, and this is the truth, there are far too many professionals signing off on things they shouldn't sign off on. That's the real reason. It's been around since 1989. It's pretty clear language in that standard. And it's, I mean, perhaps that wasn't adopted into the code until, let's say, the early 90s or something like that, but it's been around for a long time. So more municipalities are starting to point that out. And there are some municipalities outside of the Lower Mainland that are perhaps more loose with what they accept and don't accept. And so it's getting better, but yeah, there's a ways to go. There's a ways to go still. Okay, just a few more examples of instances where glass guards don't meet building code. Just really, all these are examples of not having a top cap. Even this one that has posts, you still need the top cap for post-breakage retention. If one of these pieces of glass breaks, you just have a gaping hole that someone could just fall through. But I won't go too much more into that. We will talk just briefly for a minute here about CSA A500. Now, I know that there are other standards that address guardrails specifically, like ASTM E2353. It's relevant in the sense that before CSA A500, which isn't yet in our building codes, but accepted by some of our professional bodies, there was really nothing else to go by. So, you know, testing facilities and labs would test to the ASTM standards because that's sort of all that there was. And if an engineer was okay with sort of accepting that, then that was fine. But CSA A500 is now providing a path for physical testing, if that's the path that one would like to go in getting their products certified. But it also provides a path, as we mentioned, for capless guardrails. And you can see these are real. This is not a rendering. This is an actual building where in White Rock, where you've got these long, like 8-foot panels, about an inch thick, with a specific interlayer. It's called SG, Sentry Glass. I think the only product of its kind, which I believe right now there's some shortage with. But with that interlayer, CSA provides a path, not specific to that brand, but has to have a certain mechanical characteristics that would allow it to be used in this application, where you can get away with having capless glass guards. It's obviously a little bit more expensive, but when you have that kind of house, maybe it doesn't matter. So yeah, just be familiar with what is being engineered. As I mentioned, it's not yet included in Canadian building code. My understanding, and I don't know if this is true, maybe someone can fact check this, is that it's planned to be included in the 2024 NBC, so we'll see what happens with that. And as I mentioned, it is authorized by EGBC/AIBC in professional practice guidelines. They've given engineers and architects the A-OK to go ahead and use it. And I'll refer back to that in a little bit as well. There's one more point about that I think is important. It also encourages the use of using finite element analysis, FEA, as a way to look at guardrails. As I mentioned before, sometimes we've got these stress concentrations that you really can't quantify in any other way. You can't do hand calculations to figure it out. You really do need specific software to help you figure that out. And it explains the differences between those two codes, M89 and ASTM E1300. It's got a good comparative list of what the difference is between those codes, so that's helpful as well. Okay. Now, talking about guards, can't help but talk about windows and windows acting as guards. And this is, as Dave Goldsmith knows, this is a topic that gets tossed back and forth a lot. It's a little bit more straightforward in part 3, but part 9 it gets a little bit more murky. But I've just placed a few references to where in part 3 of the BCBC and VBBL, VBBL also includes these references, but the one that's slightly different because it has some additional clauses is this reference here. Those are the references those are the clauses in the building codes for us here on the West Coast that refer to windows acting as guards. And these specifically are talking about instances in which the windows are operable. So that's important. And there's other stipulations as well. You know, some are residential buildings of residential occupancy, and there's other sort of qualifiers to sort of narrow down what these are referring to. But it sort of left the question, well, what about just windows that are not operable? Just a rectangle. What do we do with those? Do they have to meet guard? What's the minimum sill height for those? Well, EGBC, it's interesting because years ago, before CSA A500 came out, everyone sort of looked to EGBC and then APEG-BC for guidance as to what to do with guards in general. And they produced this sort of guideline for everybody to go by. And now that we have a new guideline, I feel like there's a little bit of hesitancy there. But let me try to explain what I believe this is saying. Consideration should be given to windows where the sill extends below 1,070 millimeters, approximately 42 inches. And those windows must be treated as a wall separating the elevation difference and designed to withstand the appropriate guard load. So it's basically saying, and then it does go on to say, I should mention, it does go on to say that operable windows should also have special considerations. So this is sort of saying, hey, if it's not operable, this is kind of what we need you to be looking at in terms of guard or sill height for guards, windows acting as guards. And it's sort of implied that this is referring specifically to part 3, because if it was a part 9 building, well, part 9 buildings don't require to have a professional do the review and field review of the installation anyways. In other words, you often won't need an engineer on your project if it's a part 9 building, but the fact that it's in EGBC's professional practice guidelines sort of implies that an engineer would be involved, and therefore this does apply to the part 3 buildings. So that's the short answer, is 42 inches. If it's a non-operable window, if you need guidance on operable windows and when they need to act as a guard, look at those references. The language is fairly clear, but this is sort of the guidance given to architects and engineers as to what that sill height should be. Okay, so a couple other things to just quickly go over in terms of considerations. We talked a little bit about this already, products being sourced overseas, and we will get back to that. And it's really not just the glass. There will likely be some more questions, I suspect, with regards to like the difference in thermal performance, the types of physical testing, like if it's a part 9 building. I know we're talking mostly about part 3, but if it's a part 9 building, like do their air and water tests, are they equivalent to our NAFs and so on, right? I think those questions often come up. Another consideration here is building structure. We see more and more high-end residences, for example, that are classified under Part 3, where they need a professional to review things. And large, 20, 30-foot tall sliding doors and all sorts of very unique structural things in terms of glazing, where, high reaction loads, large deflections and things like that. We can't just treat these buildings the same way that we've treated any other single-family dwelling. We need to really be planning ahead to take into consideration the loads that need to be reacted and what's going to be happening in terms of deflection and other things with the glazing. This is maybe my favorite point here. Not all glass is equal. as much as I really would love to just give a rule of thumb as to what you should use for glass thickness in your IGUs and so on, there's too many variables. There's just too many things to consider. Everything from the way that wind loads are calculated to aspect ratio of glass, whether it's tempered or laminated, guard load requirement. There's all sorts of things that go into determining what that thickness should be. And so there really is no rule of thumb. I suppose you could come up with something that would cover many, many cases, but you would probably end up specifying a really thick glass over and over again that you wouldn't want to be paying for in large quantities. And as I mentioned before, simply tempering glass does not make it strong enough. So if a window does need to act as guard, just tempering a 3 millimeter pane, the inboard pane of the glass, it doesn't mean that it's going to instantly be guard load resistant. There needs to be more thought that goes into that. Okay, final topic to cover. This one I think is probably one of the most important. So RPR. The RPR is the registered professional of record. When it comes to glazing in a project, glazing in BC at least falls under the architectural scope of a project, meaning that the architect typically, sometimes it's the building envelope engineer and others, but typically the architect is going to be the guy who does the final sign-off on all of the glazing on your project. Even though you may have someone like us, a supporting registered professional, the SRP, working on your project, we just submit documentation to them so that they can have reassurances that what we've done is okay. The reason why they do that is because they're an architect. They may not know what to do with glass in terms of making sure that it's strong enough or good enough for the application that it's being used in. And so they'll say, okay, well, we want to make sure that there's an engineer on this project that does know what they're doing, and we want them to submit to us documents formally indicating that what they're doing is adequate. So, yeah, this can be an interesting relationship. This is the ideal. This is the ideal relationship right here. It doesn't always happen that way, but that's the way we want it to be. And I don't know which one is the architect and which one is the SRP here. I don't know. And for all I know, maybe he's got a frown on his face or something. I'm not sure. Maybe he's angry, but. Okay, you may not be able to see this, so I'll kind of read out the important stuff, but this is just a hierarchical diagram of the flow of responsibility for glazing. So, as I mentioned, here I'll just point out the RPR, that's the architect right there. The architect has two documents that he submits to a coordinating registered professional, the CRP, essentially ultimately the authority having jurisdiction. And again, this is specific to BC, by the way. It's slightly different in other provinces and so on, but this is BC specific. So the RPR, when everything's said and done and everything's installed and everything is done properly, the RPR, or the architect, submits a Schedule B, a Schedule B and a Schedule CB. They're called letters of assurance. And they basically say, hey, everything has been engineered properly and it's been reviewed on site and everything meets the design intent. Everything's good. So he submits that. But if he doesn't have the confidence in and of himself, if he doesn't feel like he has the ability to truly say that, because maybe he doesn't know much about glass, he'll ask that a supporting registered professional submit to him schedules SB and SC, S being supporting documents. And they just go to him. He doesn't submit the SB and the SC to the authority having jurisdiction. They don't go to the municipality. They just go to the architect. So it's this fairly tight, or at least supposed to be, this tight relationship between the RPR and the SRP, us. This is out of the professional practice guidelines. I'm not going to read all of this, but just to indicate what some of that responsibility is on paper, what the expectation is from the governing professional bodies, the RPR must coordinate the work of the SRP. So there's supposed to be communication there from the architect. And typically the SRP SRP, the supporting registered professional, must liaise with the RPR for the purposes of field design and field review. So, so we also have a responsibility to be talking with the architect to make sure that he knows what we're doing. States here, this is interesting, the code does not, I will read this one, the code does not require, and these guidelines, these professional practice guidelines, do not contemplate that the schedules of SB and SC be part of the code mandated letters of assurance. In other words, if an RPR doesn't want a schedule SB and an SC from us, then that's okay. It's his call whether or not those documents are going to be required. But it's important for glazers and installers to know whether it is or not, because they're going to be channeling that request probably through you. And having an SRP at all, as I mentioned, is totally up to the RPR. So this is the ideal. Communication back and forth. For Part 3 projects, this is often what we find. It's not, I'm not saying that this is necessarily bad to have more parties there. It just means that things can get lost in communication. So here we have the RPR, general contractor, subcontractors who then hire us, right? So contractually, the relationship is, there's a longer string of parties there, but responsibility-wise, it's actually just 2 parties, that's it. So you can see how things start to get a little muddy. So these are some of the things that we often come across. Subcontractor maybe doesn't know who the RPR is. The RPR doesn't know who the SRP is. Subcontractor, and I'm not like pointing fingers here. This is what we commonly see. This is just the way it has been in many cases. Subcontractor doesn't notify the SRP of the installation progress. Installation becomes complete, and then they ask for the documents. Well, a field review has to be done, and if we can't go on site to see things like fastening because it's all covered up with trim and things like that, then how can we provide those documents? So it's really in the glazer's best interest to early on make sure that you know if an SRP is required, who the RPR is, and make sure that that SRP is getting on site to review your project so that you don't have to start tearing stuff out after the fact. Super important. And this doesn't happen so often, but occasionally we're told that we are not allowed to talk to the RPR and to go talk to someone else instead. That really should just not happen because I suppose you could say we have a provincially legislated legal or professional responsibility to liaise with the RPR. So that about wraps up what I wanted to cover. So thank you so much for your attention and your time, and we're going to turn some time over to our panelists and myself to answer some questions. Thank you.
Here's a situation we run into in the prairie provinces quite frequently that you're probably aware of, is that they are unaware that the responsibility for the glazing and safety within floor areas, in other words, guard loads, falls under their responsibility. And they either expect the subcontractor to take care of this in the background, or they say, we don't think we need this, but you, the glazing, the window and door fabricator, are responsible for ensuring that all your windows meet code. And of course, they do meet the prescriptive requirements for code, but if there's no supporting registered professional, the proper architectural process and engineering process is not being followed. I have a hard time convincing these guys, and the other thing is that we never get to communicate with them directly, right?
Yeah.
But is there something that could be done to educate architects in provinces where this is poorly understood that yes, if through the contract system or directly there's no SRP, it is their responsibility. They're not going to be able to dump it on the window supplier down the road that, you know, is a part of my natural expectation that all of this would get taken care of, and I don't want to pay for an SRP.
Right. I'd love to take that question. So, for example, in Alberta, things are mostly the same there in terms of what we just talked about. There's an RPR, there's all that stuff. There's slightly different documents. Instead of an SB and SC, it's like a letter of commitment and compliance that we would submit to the RPR, and he would submit a B1 and a B2, I believe. So, and a C1, C2. And so, yeah, what we have found is that there are some companies where they're supply only, and they'll hire an installer to do the installation. So from their perspective, they want to be like, okay, we're just going to sell these windows. We will get an engineer to engineer them, but we're going to stop there. And we're just going to sell them and let the installer take it from there. Well, the contractual relationship in that particular chain is fine, but from the responsibility perspective, we can't stop there. Like, we are still obligated as the SRP. We are still, in fact, even if no letters of assurance or no letters of commitment and compliance are required, we are obligated by our professional practice guidelines to still do field reviews. So even if the documents are not required, we still have to do field reviews, whether or not the supply-only company wants to pay for it or wants it at all. And so that's really critical to keep in mind, is that we have a professional responsibility. We have to know who the parties are. So I think maybe this is easier said than done, but I think my advice would be just press whoever is hiring you to figure out who those individuals are, so that we can at least ensure that somebody is taking responsibility, right? The architect may say, I don't need supporting professionals, but it's up to him to make that call, not the contractor. Does that answer your question, Dave? I'm going to stay standing up. I'm going to assume I'm going to answer this.
So what I'm hearing is always price it in. And if they don't take it, then they can leave it and go to somebody else.
Just save yourself some headaches.
Yeah.
Yeah.
Unless we have, like, in writing that the architect or the RPR, whoever that is going to take responsibility, we're obligated to do field reviews.
Yeah.
Yeah.
And I did have a couple cases where we actually received in writing that we don't require this, we don't think it's a requirement.
Right.
You put that in your files, then I guess you're safe.
Yeah.
So Jeff and Brent, I mean, it sounds to me, kind of being on the outside, I don't do a lot of Part 3, or I certainly don't now. Touched it in my early days, but it sounds like there's architects and engineers and professionals with sign-offs and guidance documents that guide how they're supposed to do their job. So it must be pretty straightforward. There shouldn't be any problems, right?
Well, okay, so I'm not familiar with Part 3 and Part 9. I've read it a little bit to understand the BC side of it, but in Toronto, what I've seen from the larger projects that I've looked after and managed, you do have the architect. However, he passes it down to the GC. GC then follows through with the architect owner as their lead. So then now the subcontractor either has to, in the specifications, have an SRP, or sometimes the SRP is sidelined with the GC who works through the owner, and they are commissioned to look after the subcontractor, but you both need to work in tandem. So it is complicated, but I would agree that if there's anywhere where you see gray areas, yeah, include it in your price. A lot of times the amount of that with the field visits, if it's a large project, is very minimal in percentage wise, and you're covered then, right? That's the way I look at it.
Sure, and for us, we're often doing smaller jobs where we're putting it as an option and then getting in writing and saying, hey, you know, do you need this? And there's a lot of confusion. We're having to guide the GC through the process.
So what's the best tip for a glazing contractor then? You know, who needs to be in play, and what's that sequence of how they get through the process?
For sure. Well, what we strive to do when we take on a project, when we're hired by a glazing contractor, because that's our predominant customer base, is we right away, before we do any engineering, get them to fill out a document that basically says who the RPR is and the information of that RPR. So then we can immediately issue an SB. That first of two documents, and I will just quickly reiterate what those are. The first one says, the first of two says, I as an engineer am taking on the design portion of this, the scope that I'm covering, and I promise to go on site to review it, to make sure it's done properly. And then the second one says, I went on site and it was all good. So that's what those two documents are. Or it's, yeah. If it's no good, then we make sure it's good before we give that document. Yeah. So, yeah, I mean, outside of that, what can we do? Well, I think just being aware in general of what the requirements are. And if you're not sure what the requirements are, there's lots of people you can ask. And so, yeah, the information is there for sure.
Yeah, the other thing I'd point out is I find with the project managers who have a lot of work going on, they're usually dumped the specifications from estimating who have read it in order to get the estimate. But it's those little things that I'll spend a week reading them and highlighting and tabbing all the important things that fall into that category where you gotta watch for SRP.
Yeah.
Because it'll be in there. I've even run places where it says you need to have an NCSO, which is a National Safety Officer, on site full-time, and it didn't happen, so
Yeah.
we had to find somebody right away.
Yeah.
So there's these little tiny things they throw in there. So if you're not carefully reading all the details in the giant manual, you're going to miss it.
Yeah, yeah. Yeah, in Ontario it's a little bit different. Like in Ontario, you can actually have a review-specific engineer. You can actually split those responsibilities a little bit more clearly. So yeah, just being familiar with what the process is important. Yeah.
So, sorry.
Go ahead.
So correct me if I'm wrong, but the overhead glazing or the balcony guards, was the catalyst for that the spontaneous breakage of the? Yes. Was it from? Was there a point in time where people were falling off balconies and dying? Why do we have such a rigid, strict code for that, where the top cap and LAMI?
I don't know all the reasons why they would have made the code the way it was. I mean, in 1989, I was 9 years old. That lets you know how old I am. So I don't really know what would have went into that, but I think that's part of it. I think that would have gone into it for sure.
But you can use heat soaking if you want to get rid of the. There's other alternatives. It just seems so over-engineered.
Sure. So two more comments on that. So one, I think that was part of it. I think another part of it was just the fact that it's glass. It's brittle. I mentioned before with how easily tempered glass is broken when you tap the edge of it. Right? There's so many instances in which you could potentially, I don't know, carrying a book bag with a carabiner on the back of it, and it swats the edge of the glass, and the glass is gone. Right? So there's lots of ways, certainly more ways that glass can break than, say, a steel panel or something, or even a wood picketed fence. Right? So I think there should be some additional, we'll call it safety measures put in place to guard people, no pun intended, guard people from falling. So yeah. We had another question here.
3 quick comments. Al Duick, Duxton. I've been in these kinds of meetings, I think, for about 20 years, and the shading coefficient issue has been, I think, frustrating many of us window manufacturers, because there was one side of this, Ottawa Energy was high shading coefficient through and through. They wouldn't listen to anything else, and I think to a point it still is that. Some of us have dealt with the consequences. One comment on that we have taken upon ourselves is to work very hard at work in your offices to educate you about the different types of low E's that are out there. And then you have the ability to basically, as far as I'm concerned, use low-hanging fruit to design buildings that use modern technology. So it's funny it's odd to see how that transition happens. Secondly, the transfer of specs on some of these light commercial types of buildings is kind of interesting, because the cut and paste happens so much.
Right.
And part of what's going on now is from our window installation detailing, rain screen versus a nailing fin, which does not respect any of those considerations, has become a bigger and bigger issue as wall systems have become more complex. The reason for which I want to just comment briefly for the sake of our industry is a couple things. My understanding is the National Building Code is going to switch to a rain screen installation detail beginning next year. I don't know how aggressively that is being put in how many parts of it or all that, but we're finding the architectural community is not really aware of it. So the cut and paste of the other specs are going in. But certainly one of the higher quality firms in Winnipeg has actually now engaged us to work with them to work out installation details that they're comfortable with and build a physical example that allows them to educate their spec writers and people so they know, what is this? How do I do this so that I'm confident that there's enough blue skin in there that they make enough money? Just kidding.
Sure.
But that the whole detail is actually properly done, right? That the interior seal is there, that there's exterior drainage capability, that it's appropriately done. And last point, which very much ties into this, in the last few years, there has been a deeply concerning trend coming out of Manitoba where the commissioning and testing is written up in such a way that one of the most experienced testing guys in Winnipeg with Intertech basically described it as suicidal for my industry. So if you're going to do a massive amount of testing, and then in this particular spec, which is emerging in a few places now, is for every failure, you test 2 more. So now you got to retest that plus 2 more. And the reality is that I think is a real threat to our industry. It can be enormously expensive. Is, as my daughter, who's smarter than I about some of this, comments, that you're dealing with a whole bunch of different stuff. If the skin in the building isn't done right, the membrane is reversed, as they are in some buildings. Great detail. Or if the installer hasn't done a great job, this hasn't even talked about the window yet, right? And then you finally get there, and if any one of those 3 has any amount of pinhole, any problem, and you have a very, very high negative pressure test for water, which is the devil of all of this. So I just wanted to take 2 seconds, because I think a few people here, when you go into multi-story buildings, certain institutional, educational facilities, it's more and more a case where that commissioning and testing is going to bedevil people. And from a design community, again, we are going to work pretty diligently to try and connect between us to say, what is that detail that works?
Those sound like some great pain points. I don't know if anyone can commiserate with that or have anything that could maybe help with that, or is someone on our panel here too?
So I know for myself in large buildings that I've done, multi-story, 100 stories, a lot of times written within the specs from the architect is a requirement to do certain testing. Whether it's unitized systems in the plant, you might have to do some negative pressure and positive pressure. Yeah, and then in the field, you're right. When it comes down to the labor component from the installation, you need to do it early on, because if you don't, then they're going all the way up the building, and you end up with a massive problem, you know. So that's part that we at the companies I've worked for always inbred that. So if it's 100-story, maybe in the first 2 we capture some, then we go 10, then 30, and so on. Because for us to take all that down and try and fix it after the fact, or trying to find water, I've had to try and find water in 30-story buildings, and it's like trying to find a needle in a haystack times 10.
Well, Al, I just wanted to say that we do have a task group regarding field water testing and having some Fenestration Canada recommendations that are hopefully going to deal with that topic, which is a completely separate topic from the structural. I also want to commiserate with you when we see cut and paste specifications. There's some ridiculous specifications in there. Quite often I see L over 200 deflection for the glass, and we just ignore that. It's not part of the deflection is not a part of our glass strength considerations, although the software that we use will warn you when it's got excessive deflection. It'll say this is strong enough, but it's subject to excessive deflection. But, you know, we've never, as far as I know, you guys don't do a glass deflection analysis. Is that right?
Yeah, there's an edge of glass deflection limit that's articulated in a few places, one of which is ASTM E1300.
Yeah, that's L over 175.
That's
but
right.
they're talking
But
about
center
glass.
glass. Center
L over
glass,
200.
there's really no specific
Yeah.
code
Yeah,
embedded.
it's
number.
written into some
Yeah.
of these specifications,
Yeah,
and
yeah.
like a lot of the junk that is in there gets ignored. Now, I know we're almost done here. I just want to throw one more thing at you. What we're starting to see in some jurisdictions in Part 9 for windows and stairwells and landings, they want a letter from a registered professional engineer saying that this meets the requirements. which is a really onerous thing to put on a lot of window companies that don't have engineers.
Yeah.
Is there anything we can do as an industry to say that a typical stairwell and landing window, like 4 millimeter tempered, does it? So that, because they used to just look for tempered.
Yeah,
And if that was good enough, and then somebody told them, some clown told them, that the minimum tempered glass thickness to meet guard loads is 5 millimeters, and now they're challenging every window to get a letter from an engineer. That's it, and I've all I'm going to say today.
So let me quickly comment on that, and then I think you've got some more questions here too, right? So if that's okay, Terry. I've been thinking about that. I think, at least from my perspective, because what can I do other than try and do something myself, right? I think what we could potentially do is, when we know that there's going to be a landing or something like that on our drawings, and sometimes we don't know, because sometimes we don't get very complete drawings that show where the landings are, so we have to make some assumptions. And so if we knew where those were, we could put some sort of a disclaimer or something on the drawing, or a note on the drawing saying, specifically, this meets, you know, the particular instances in which there are those guard-related locations, they meet the code-related clauses of the building
That's
code.
what you do if there was professional design and review for the project. But this is what we get. Occupancy is in 2 days. I need a letter tomorrow, or
Yeah,
else you're in big shit.
It is confusing, because you would think that if an engineer reviewed and engineered your whole drawing package, that would include the aspects that relate to guard. But apparently, that you're right. That's often not
Part
good
9
enough.
homes in BC, single-family homes, it's becoming very common where building officials are looking for professional guard load design on windows, not just on landings and not just in stairwells, but also on second floor, third floor,
right.
where the windows are below guard height. So it's a much bigger deal now than it was before.
And to your point, Dave, one of those recently was not only did you want to have deal with the glass, but that your window stop on the window stop on the outside was evaluated by an engineer properly to assess the materials were tough enough to stop the glass from not gate popping. Anyway, to your comment just for 2 seconds about your test process, the difficulty that we've experienced in some of this, I'll just put this in context. Take a project where a window supplier is shipping $250,000 worth of windows, and the projected cost of testing those is going to be $150,000. Does that make sense? No. Zero. No. So your recognition, which I respect highly, of a comment that the purpose of this is to start early, to determine that the procedure of membranes, the installation people doing what they're doing, and the window itself, which has been pre-tested in an independent lab to verify that it's doing it, sometimes quite large windows, you have to now break up altogether, site glaze, blah, blah, blah. We've got no difficulty with that. That makes sense. To go to site and test a couple to verify that what they're going to do early on is right, find mistakes and problems, solve them, and now proceed. But the other concept of what is embedded in some of this, I just want to raise a flag to some degree on this, is that, more than a bit, is the objective is a little different. I've described it a little bit like having the pox in the hen house. It's pretty good to eat there if you're testing, right? The concept needs to make sense. And some of what is rising into more and more of these places is not. And that's the issue. There's no issue with making a quality product, no issue with working with a proper installation, and good designers who have the right thought. Thank you.
The other thing just with that is that testing part that I mentioned is, yes, it's expensive, but you know there are other ways of doing it, because I've had to actually go to sites and review buildings on a more weekly basis or something. So I mean, as somebody who is familiar with what that system is and what you're looking for, you can capture within a quality person that can go and do that. And then you could do a lot less of the testing then, right?
Yeah, I guess my question is going back onto the glass, like sealed units, glazing. I think Terry brought up that, you know, questions about liability, glass coming from Europe. I think this is a bigger issue when we were having some significant shortages of glass a couple years ago, things like that. But I'm curious because we were approached a number of times with, hey, can you, you know, our you know, inspector or whatnot, or consultant is saying this glass, you know, doesn't have the stamp, or, you know, hasn't been tested. Can you guys, you know, test this? And I think one of the big realizations that people don't realize is that to test that glass, sealed units,
tempered glass, whatever, it has to be in specific sizes from that specific facility. You can't send me a piece of glass from the site or send me a sealed unit from the site and get a result. And I don't really know how some of those were resolved, because I know that glass didn't arrive at my location. So is there an alternative pathway for guys getting already installed glass that doesn't have a mark or hasn't been IGMA or IGMAC tested, approved for a site?
Yeah, I think the short answer is no, and I mean I hate saying that. Having said that, though, if it's a glass manufacturer that is normally providing glass to a Canadian market, they should already be qualified and accredited to be able to place the appropriate etching. And if they're not, then I would just question who the glass manufacturer is.
It's been going on for a long time, though. I
And-
mean,
and
import products that are not tested to Canadian standards, that's nothing new.
Yeah.
We've been seeing that for decades.
So I think in that particular case, I could see the potentially, if the information could be validated from that glass manufacturer to show, like some sort of a certificate or something saying, the glass that we produced in this heat lot also meets this Canadian standard. I could see as a professional saying, okay, all right, you know, I think this might fly. But, you know, unless it was something pretty solid, I think it would be hard to say, yeah, okay, that's good, just because it doesn't
Or
mean it.
have them do some testing in Canada. Hey,
Yeah.
problem solved.
Right, yeah.
Okay, we're out of time.
Yeah, awesome.
There is a membership meeting coming up very shortly here. So, John, thank you very much. Guys, thank you. Thank you, everybody.
Wait.
Yes, indeed. Thanks, everybody. So once more, before we call it a day, thank you to our sponsors. There are so many sponsors this year that we're so grateful for. It's fantastic.